Okay, so lesson 5 is all about understanding association and correlation or causation. Okay, so a study shows that a number of times students skip breakfast has a negative correlation with the students. What does it mean? Well, it means that if you skip breakfast, you have a higher likelihood. If one skips breakfast, let me make this bigger a little bit. If one skips breakfast, then that student, we'll say if a student skipped breakfast, then that student has a higher likelihood to perform poorly on an exam. Right? So if you skip breakfast, there's a higher likelihood your score will go down. Or we'll say a higher likelihood to earn a lower score. Okay. Does this mean that not eating breakfast causes students to do poorly? No. The correlation is kind of like this is one of the things that that might affect the score, right? There could be other contributing factors, right? So what other factors might cause this association, right? So correlation is it could be a thing. There was some recognized data to support this, but it's not necessarily the reason why, right? So what other factors might contribute to someone who misses breakfast and doesn't do well? Well, how about if they were late, right? They were late and skipped breakfast. Right? Maybe, and because they were late, they rushed to prepare, and then you kind of kept up that tempo in your mind. Okay. She was telling you maybe that's some sort of and just because you're hungry, just because a student is hungry does not mean or is not hungry. A student is not hungry does not mean that the student understands the material. Right, so that is a material just because. So there's an association. The association is, as the number of people who skip breakfast go up, the scores go down, but it could be other things, other factors that might contribute to this association. So the correlation. So correlation is just like describes a relationship between variables. It could be a strong or weak correlation, but a correlation does not necessarily mean there's a causation between the two. Right, so if there's a correlation or an association, they're the same thing, correlation, association between two variables, it does not mean that one causes the others. Right, two variables can be correlated without having a direct relationship. Okay, a causal relationship. Okay, what other information would be helpful? Are the tests only opened in the morning? Right, only offered tests in morning. Maybe compare the correlation between of other classes of other periods. So maybe someone right before lunch would probably be hungrier. That would indicate that you're probably going to be hungry before lunch. Might do more poorly, and if that you see that correlation there, then maybe then you can might feel support that it's a cause. It's a cause. Okay, it's not really eating breakfast; it's being hungry. That's really the what it gets down to. All right, so here's another example. At a theme park where there's a positive correlation between the amount of rainfall and the number of ponchos sold. Well, that's pretty much common sense. The more it rains, the more they're going to sell ponchos to keep the rain off of people. Right, so that's what that is. Right, what does this mean? Does this mean the increased poncho sales lead to more rainfall? No, of course not. Of course not. Right. It would seem to me here that the amount of rainfall, right? The amount of rainfall would be your x-axis or your independent variable. And it just depends on how many calls there are. And y is your number of ponchos sold, right? So the number of ponchos does not drive the rainfall. The rainfall drives the ponchos, but it doesn't mean that there's a correlation, right? Because you could have just bought ponchos because there's rain in the forecast, or they're on sale, right? At certain dates. So there could be other things, right? So maybe they wanted to protect them from water rides. Right? Maybe they wanted to protect, maybe they were on sale on certain days. Maybe the forecast called for rain, but it didn't actually rain. Right? So there's lots of different things. Right? And also, they should have said, does this mean it should have been, does this mean that the more rainfall led to more poncho sales? That's what it should say, to make a more challenging question and have answers for different reasons. Right, so there's that one. Okay, all right. Now there's ski resort, snow accumulation. So as snow accumulation goes up, injuries go up. Right. So what kind of this is a positive correlation. It would be negative if one went up and the other went down. Just do this. This is a positive correlation. Positive correlation. Is there evidence to support this? Yeah, there's some evidence. There is some evidence to support that as snow goes up, injury rate goes up because they plotted it. But what other would be helpful to claim this causal relationship? So what other things would we have to rule out or identify to say, yep, as snow goes up, injury rate goes up? We would have to say the type of injury, and how it was received, right? That kind of stuff matters. And were they if they were received directly to the snowfall, then yeah, that makes sense, right? Was it skiers, or was it just who was injured? Who was injured, right? Was it people skiing? Was it just people driving in the snow and they're trying to push out their car and they pulled a hamstring or something? So who was injured and how it was injured? Maybe they weren't even skiers, right? So so that's the type of things that you have to recognize. So just because something appears to cause another does not mean it's a causal relationship. Hope that makes sense. Right.